Okay, well, evening. We looking at quality management. Under quality management, we're getting down to assignment review. Okay, so for the assignment review, we are looking at the first number one under quality management. Okay, one thing we should look at is the cost of quality. Okay, first and foremost, we'll have to look at the cost of quality. Categories. What are the categories here? Number one category is look at the prevention cost. Then look at appraisal cost. Then you look at the internal failure cost. Then look at the external failure cost. These are the cost of category, cost of quality categories. All right. So all these are the ones that we have. Okay. So we can now get into the other thing. All right. The other thing that we are getting down to is control limits. Okay. So we have what we call control limits. Under control limits, we have X bar chart. X bar is the center line. Our control limit is got X bar plus 3. Okay. SD over the square root of N. Upper control limit is got X bar plus 3 SD over the square root of N. This is it on how we are looking at the X bar chart. Okay. When we get down to the C chart, this is called number of defective chart. So our C bar is the center line. C bar is that's the C bar is the center line. And then how we get the C bar is equal to summation of x over n. This is how we get the C bar. Then getting down to the lower control limit is equal to C bar minus 3 is standardized over the square root of C bar. That is LCL is the lower control limit. Lower control limit. Then upper control limit is equal to C bar plus 3 the square root of C bar. This is about what we have concerning the control charts. All right. This is about what we have concerning the charts. Okay. Then getting down to the P chart. P chart is a percentage of defective chart. P chart. So our P chart is a percentage of defective P chart. Okay, so this is the percentage of defective chart. So meaning that P bar is a center line. Then lower control limit is equal to P bar minus 3 P Q over N. Upper control limit is equal to P bar, all right, and plus 3 PQ over N. Then our other chart, this is called the range chart. So R bar is the center line. Lower control limit is equal to D3 R bar. Upper control limit is equal to D4 R bar. These are what we have concerning the chart. Okay. So now we can get down to all right, so we can get down to what we have here. Okay, so this is what we have concerning this one. Okay. Then we have this one here. So under this one, we are simply saying that as we get down to this business, we have solutions here. All right, so meaning that the first one is a C chart, which is the number of defective chart. So this process is not in control. Not in control because for a number of times, okay, number of injuries here, 1. We have the C bar is a center line, and then looking at what percentage of defectives are we talking about? We have this one here, that, or what we have for the first one, 23 is far away above the control chart. Okay, so it's above the upper control limit. Okay, so it's above the upper control limit. So meaning that this process is not in control. All right. So here we're simply saying for this one, because this one is up above the upper control limit. This is the center line. This is the lower control limit. So this one, for one of the months, is above the upper control limit. So the process is not in control. Okay? The process is not in control because one of them has actually been above the control charts and control limits. Okay? Okay, so this is about what goes on as we look at the control charts. Okay. So this is the center line, the lower control limit, the upper control limit. This is the center line, lower control limit, upper control. Now, for injuries in the one, the process is not in control because July, the number of injuries above the upper control limit of 15.2. It is outside the boundary of control charts. Okay, so this is about what we have. Then getting down to the other one, also, this one is not in control, all right? Because this one is above upper control limit of 9.86. So it's not in control. These boundaries are the ones that we actually look for, all right? So then we get down to the second question. Second question, we are talking about the cost elements. So prevention cost, the quality, the new product development, the quality training. We have this one. Out of the total is 99,200. We are simply getting 4.23, which is a percentage of the total. Appraisal is 30.75. And then here is 36.29 according to these are cost of quality element. So this is cost of quality elements. Under cost of quality elements, we have about 4. We have the first one is prevention cost, the appraisal cost, we have the internal failure cost, and the external failure cost. These are just the 4 cost of quality. So the 4 cost of quality, there are 4 of them actually. Okay, so the four cost of quality, we have four. Number one is prevention cost. So under the cost of quality, um, we have prevention cost. Then we have appraisal cost. We have internal failure cost. External failure cost. So these are the four costs of quality that we actually have. Okay. So this is just about what we need to know concerning anything else that we are doing right now. Okay. So this is what we have here. So from the above cost annual report, the internal costs are very high. Okay. The appraisal and internal failure costs are very high. But the internal, okay, internal failure and appraisal costs, these are very high. So what we are simply saying is that they are very high as compared to prevention costs. So this clearly shows that the company is more inclined to appraisal as a means to ensure conformity. Appraisal does not build quality in the product. Therefore, the company should consider investing in prevention costs so that they can mitigate the risk, mitigate the, the risks. So this is about what we have on question number 2. So in control and out of control depends on the boundaries of whether it's above the control limits based on the calculation. Then getting down to the last question here that we're looking at to do with the progression. So the company progress in improving quality and reducing its quality cost, sales minus cost. Okay, so meaning that 81, so meaning reduction from 100 is 18.08. Sales as was given the question as 50,000. The total cost of quality was 99,200. So meaning that you have 81.92, and the reduction from 100 is about 18.08. Now, since for the company year management plan to reduce quality from to 18% of sales, meaning that the deviation from this is very minimal. So the deviation is this one. So the figure is within stated management policy of 17%, which is not very bad. All right. Now, getting down to question 3. The CP and the CPK are two common indices of process capabilities that we know, and as we get down to the question, okay, the question that we can get down to, okay, so we are simply getting down to the question. So Okay, so now so this is just about what we have here concerning the question 3. So for question 3, we have the CP and the CPK are the two common indices of process capability. So this one stands for process potential, and it measures the ratio of the specification range to process variation. ARCP means that the process has more potential to meet the specification. And of course, we have the other one where where we have a CPK. The CPK stands for process performance, and it measures the ratio of the distance from the process mean. Okay. Okay, so this is the CPK stand for the process performance, and it measures the ratio of the distance from the process mean to the nearest specification limit divided by the half of the process variation. A higher CPK means that the process is more capable of meeting the specification. Now, the CP is equal to upper specification minus the lower specification over the 6 sigma. This one simply means upper specification then this one is simply means lower specification limit. So the CPK, we need to also look at the minimum of these ones. All right, and then we're simply saying that the CP is 1.26. Well, this other one is 0.88. Now using the CP, the process is not capable because 0.88 is less than 1, which is a standard. Okay, so for the CP, the process is not capable because the 1.26 is less than 1.5. The standardized for this one should be 1.5. So this one, we simply say process is not capable. Then the other one here, where we are simply looking at the 0.88, okay? The probability for these ranges that we are looking at, proportion of meeting specification, we are using this one and this one. The proportion is 49% or approximately 50%, which is within this boundary for normal distribution. And then the adjustment, meaning that the mean should be adjusted by 0.5 or reduced by 0.6. So mean should be reduced by 0.6. So mean should be reduced by 0.6. So meaning that after this, we are getting this, which means that the CPK, which is greater than 1, means that process is now capable of meeting specification because it is above 1. CPK is now above 1. So the process is able to meet specifications. So under the control charts, like I mentioned here, we have a cost of quality, which is prevention cost, appraisal, the internal failure, external. We also look at the lower control limit, for an X bar chart. So X bar is a center line. The no control limit is equal to, okay, X bar minus 3. All right. This over the square root of n. Upper control limit is equal to X bar plus 3 over the square root of n. C chart, which is also called number of defective chart, number of defective chart. So C bar is the center line. Our control limit is equal to C bar to minus 3, the square root of C bar. C bar plus 3, the square root of C bar. So this is what we have concerning these ones. All right. So this is according to what we have concerning these control charts. All right. And again, we're getting to the P chart. The P chart is a percentage of defective chart. So P chart is equal to percentage of defective chart. So P bar, P is the center line. Low control limit is equal to P bar minus 3 PQ over N. Upper control limit is equal to P bar plus 3 PQ over N. So this is about what we have concerning these ones. All right. So the other chart, the last one, or the range chart. R bar is the center line. Lower control limit is equal to D3 R bar. Upper control limit is equal to D4 R bar. So this is marks the end of this assignment review that we have looked at. We'll get into details of whatever it is that we are looking for. All right. So please take note of what we have right now. Okay. This is just about what we have. Okay, so this is on what we have concerning this kind of the control chart. All right, so we can end here for now. Okay, so we can end the class for now concerning this kind of paper for the control limits, for the control charts. All right, and then okay, so this is about what we can get, and well, this is what we have concerning the control limits. All right. Okay. So we can end the class for now.